The Mini-Star and BioStar use positive pressure, which gives you superior adaptation to your model, ensuring the accuracy and fit of your appliance. These machines can significantly reduce your lab expense by increasing the variety of appliances you can do in-house. Most of the technique videos in our Resource Center feature the BioStar because that's what we use in our commercial lab at Great Lakes. For most dental practices, the Mini-Star is ideal. You can use the Mini-Star to fabricate the same extensive variety of appliances that you can with the BioStar.
A variety of splints are available for occlusal and temporomandibular joint disorders as well as muscle deprogramming. Due to accuracy and flexibility, often a thermal-formed plastic is used to make the foundation or template of the splint. Then a hard cold cure acrylic is applied to customize the occlusal splint design. A naphologic articulator mounting such as the SAM3 articulator is recommended when fabricating occlusal splints possessing eccentric guidance or when vertical alteration for appliance fabrication is necessary. Remove the model from the articulator of which the splint will be anchored. Prepare the model by defining the anatomical contours with a lab knife and fill voids with a quick setting stone such as snapstone. Moderate undercuts on the model are blocked out using a model block, Great Lakes Compound 101, or Great Lakes Blockout Gel, which is light curable. Also, an isofolin material may be used as a model release or minor blockout agent. Clamp this 1/10 millimeter thick plastic into the pressure chamber. Enter the heating time of 25 seconds into the machine and pack the model into pellets. Swing the heater over the material to start cycle. Then form material over the model. Allow form material to cool under pressure for 30 to 60 seconds. Once the material has cooled, release air pressure and unlock to swing open chamber. Heat a lab knife with torch. Cut out excess formed isofolin material around perimeter of model. At this time, plastic that will be used for appliance fabrication can be made. The isofolin will not stick to the thermoformed plastics, thus no separating medium is needed. Liquid separator will be necessary if the isofolin step is omitted. Apply liquid separator to the model anatomy with a brush. Remove pellets from the cup to allow the model base to be at the height of the cup's rim. The heel of the model should be facing the open chamber to the left. Apply pellets around the model to fill gaps to the cup's rim. Then with a brush, adjust pellet level 1 to 2 millimeters below the gingival margins and remove pellets from the center of the model. A 1.5 or 2 millimeter thick splint biacryl disc is used. Peel the plastic film from both sides of the material. With a sandpaper mandrel and a 4-inch length of 150 grit sandpaper, roughen one side of the disc. Place the roughened side of the disc to face down into the chamber and clamp in place. Incorporate the material's heating time or BioStar code into the machine. Swing the lamp over the clamp material to start the heating cycle. At the end of the heating cycle, remove the lamp from over the material and slowly flip the chamber over the model in the pellet cup. Lock the chamber in place to start the forming and cooling cycle. Allow the formed material to cool for about 2 minutes, then evacuate the pressure from the chamber. Unlock the chamber and clamp material. Then swing open the chamber. Remove the model with formed material from the cup. Scrape pellets on the model and plastic back into the cup. Using a handpiece and 3/4 inch lightning disc with a standard mandrel, cut plastic to the heel of the model. Then cut the plastic along the model at the pellet level. Place the model with cut template on the articulator. Equilibrate the template as needed to maintain required vertical opening set on the articulator. The articulating model should be wax relieved to protect teeth during the acrylicing process. This will allow conformation of centric stops against splint. Brush on biacryl monomer to prime template. Splint biacryl resin will be measured by volume. 10 milliliters of monomer liquid will be mixed with 20 milliliters of polymer powder. Once the resin mix becomes a dough-like consistency, apply it to the top of the template and close the articulator. Place the articulator into a humid pressure pot to cure acrylic resin. Pot temperature should be approximately 120 degrees Fahrenheit and pressure regulated at 20 psi. Cure in pressure pot for approximately 15 to 20 minutes. For most splints, the cusp tips and incisal edges are marked using a number 2 pencil. Then the acrylic is reduced to maintain pinpoint cuspal and incisal marks. A grinding stone and a high-speed quick chuck lathe is used. A splash pan with vacuum system is recommended. A detailed trim of the functional surface is accomplished using a carbide taper burr and lab handpiece. Protrusive and lateral guidance can be established in the anterior segment of the splint. Then the splint borders are cut out with a 3/4 inch lightning disc, and then the splint is removed from the model. The splint is pumice and polished using the same procedures outlined for the Hawley retainer. Once finished, place the splint back onto the model and verify centric stops are preserved.
These technique videos, along with the other information on the Resource Center, can show you how to get the most from your machine and how to ultimately take control of your lab bill. Maximize the potential of your mini-star.